Our topic is density, and after watching this video, you should be able to recall and apply the formula of density to describe the method to find densities of objects of different shapes, compare densities, and to decide which object floats and which object sinks when immersed in a liquid. Mass per unit volume is called density. The formula of density is mass divided by volume. In symbol, it is rho is equal to m divided by v, where m is mass of the body and v is volume. The unit of density is kg per meter cube. Now, if you look at this formula, density is inversely proportional to volume for a fixed mass of an object. That is, if volume of an object is more, its density will be less. If volume is less, density will be more. Now, for instance, it's 5 kg cotton and it's 5 kg stone made up of iron. This 5 kg cotton occupies more space, so its density will be less, while this stone occupies less space, so its density will be more. And that is why this iron of same mass feels heavier while this cotton feels lighter, that is, it is less dense. Now finding the density of regular shape objects. Regular shape objects, for example, sphere, cube, and cylinder. Finding density of sphere, for example, the first step is to measure the mass of the sphere using digital balance or physical balance, and we call it m. Now we find out the diameter of the sphere and we divide it by 2, we call it r, which is radius. Now we use the formula of volume of sphere, which is 4 over 3 pi r cube. And after calculating the volume, and we have already mass, which is calculated by using the balances, the digital balance, we use the formula of density, which is mass per unit volume, and in this way we find out the density of sphere. So we need two things, mass and volume. Next is the density of cube. Now here the first step is to measure the mass again, then find out the length of one of the side of the cube, and then apply the formula volume is equal to L cube, which is the volume of cube basically, and then we apply the formula rho is equal to m over v. So in this way we find out the density of cube. Now let's find out the density of cylinder. For this purpose, again the first step is to find out the mass, which is m. Then we find out the radius by using the vernier caliper, and the height by using ruler or by using the vernier caliper if it is a small cylinder, or by using the meter rod if it is a big cylinder. Then the volume of the cylinder is pi r square h, and then the density is equal to mass divided by volume. In this way we will find out the density of cylinder. So for cylinder we need radius and height and mass to find out its density. Now finding density of irregular shape object. To find out density of irregular shape object, we follow these steps. For example, we have an irregular shape object as shown in figure. The first step to find out the density of this object is to find out the mass of this object using digital balance or spring balance. After finding mass, what we do, we take an empty cylinder, we put some water in it. After putting water, we measure its level, that what is the volume of water, and we note it with ourselves. The next step is we drop this irregular shape object in this water very carefully so the splashes are not produced. It would be much better if we tie it with a thin thread and we drop it carefully in the water. After dropping this irregular shape object in the water, the volume of the water rises. And what we do? We measure the final volume of water. Then to find out the volume of the object in water, we use this formula. That is V2 minus V1, and that gives us the volume of the object. After this, we use our formula, density is equal to mass per unit volume. While mass is calculated using digital balance and volume of the object is calculated by water displacement method. Idea of sinking and floating objects. Why a needle sinks in water, but a large ship having thousands of kg mass floats in water? There are so many other explanations, but as our topic is density, so we are going to explain it in terms of densities of objects. So here we are going to compare densities of two objects, that is the liquid and the object immersed in a liquid. So we consider a few examples. Number one, if the density of an object immersed in a liquid is less than the density of liquid, then it floats on the surface of liquid. For example, density of plastic is 0.92 grams per centimeter cube and that of pure water is 1 gram per centimeter cube. It means that the density of plastic is less than that of density of water. As a result, it floats on the surface of water. Now consider another example. If the density of the object immersed in a liquid is equal to the density of the liquid, then the object partially floats on the surface of water and partially it is inside water. For example, density of ice is equal to density of water, and as a result we can see that here is a piece of ice, it floats, partially it is outside water and partially it is inside water. Now if the density of the object immersed in a liquid is greater than the density of the liquid, then it sinks. For example, density of iron is 7.874 grams per centimeter cube and of pure water is 1 gram per centimeter cube. That is, the density of iron is greater than the density of water. As a result, it sinks in water. Here is a small iron needle which is inside water. It sinks in water when it is placed in water. Similarly, the density of gold is greater than the density of water, which is 19.3, while water is 1 gram per centimeter cube, and that is why there is a gold ring inside water. It is sunk. Floating a big ship and sinking of a small needle can also be explained on the basis of forces acting on these objects. When an object is immersed in water, there are two forces acting on the object. One force is the weight of the object, which is always in the downward direction. The second force is in the upward direction and is called upthrust or buoyant force. Now, if the weight of the object immersed in a liquid, which is in the downward direction, is greater than the upthrust, then the object sinks, like the needle sinks in water, because there is less upthrust on it. And upthrust of a liquid mostly depends on the volume of the object. As the volume of the object, which is the needle in this case, is very small, so there is less upthrust on it, and that is why due to weight it sinks. But a big ship displaces more water as it is having larger volume, so the upthrust or the buoyant force is larger on the ship, and we say that the upthrust is greater than the weight of the ship, and that is why the ship floats on the surface of water. Now let's wrap up today's points. Density is mass per unit volume. Its unit is kg per meter cube and the formula is rho is equal to m over v. For finding density of regular shape objects, the first step is to find out the mass of the object. The second is to find out the volume by using the formula. The third step is to use the formula of density, which is mass per unit volume. For irregular shape objects, again the first step is mass to find out. The second is to find out the volume of the object using measuring cylinder, that is water displacement method, and then use the formula rho is equal to m over v. If the density of an object is less than that of the liquid, then the object floats. If the density of object is equal to the density of the liquid, partially it is floating while partially it sinks. But if the density of the object is greater than the density of liquid, it sinks. Thanks for watching and kindly subscribe the channel if you haven't yet.